So, very good morning, my dear students. I think in the last class we were just discussing regarding some numerical problems. So, I just asked you people to just come solve that problem and put it in the Google Classroom. Okay. So, we will have another one problem today. So, which is an examination problem. They asked for 10 marks in your exam. So, we will solve that, and at the end, so I will discuss one simple case study question on DFMA. So please understand the case study question, because case studies are very, very important in DFMA, right? So as you go for any professional life, so definitely the case studies, the understanding of the case studies and the application of the DFMA is very, very important for you. So therefore, afterwards, we'll have a little bit of a discussion about the case study. So one simple case study we will discuss, and I want interaction from you people also on later stages. Okay. So before that, so we'll have one problem to solve. So please take a sheet of paper and a pen, and please make a note of this problem. It's a very simple problem, but it is an examination problem. Problem is appeared in the examination for you. So let me solve that problem, and afterwards I will take you for discussing the case study. Okay. Yeah, please make a note of this problem. It is desired that an end-to-end assemblies of four equal parts have an tolerance u suffix a equal to 0.200 millimeter. 0.200 millimeter. Find piece part tolerance that should be specified by first one, arithmetic rule. Part of the video has been second one, displayed. Normal law. Now we will continue that one. You see that one. Third one is the normal law with the truncated. Normal law with the truncated. This one has appeared. One standard deviation. The video slide has come. Okay. Why I'm showing this all of this carefully? Okay. So this is a very simple problem. From this video, okay. So what we have here is, it is desired that an end-to-end assemblies of four equal parts have a tolerance UA equal to 0.200 millimeter. Find the piece part tolerance that should be specified by three different rules they have given. One is arithmetic rule, second one is a normal law, third one is a normal law with a truncated one standard deviation. Okay. So now let us start with the problem. Solution is the arithmetic rule. The sum of the piece part tolerances will be equal to the individual. So I think when I discussed the arithmetic law, I think here arithmetic law or sure fit law. So I think this you can understand here. So what's happening here is the sum of the UA. It is the sum of the tolerance obtained by adding the individual tolerances of the parts. Okay, this is what we discussed when we discussed arithmetic rule or a sure fit law. Okay, so here also, so what we have, one of the advantages and disadvantages of hydraulic power plant. Yeah, so we have four equal parts. They say four equal parts in the sense, so U1 is equal to U2 is equal to U3 is equal to U4. So that is the sum of the tolerances is equal to the sum of the tolerances of the individual parts. So since there are four equal parts, so this will constitute 4 into U. If we take that as a 4 into U, so UA is equal to 4 times U. So U is equal to UA by 4. So 0.2 divided by 4, you will going to get 0.01. So this is what we will going to get it for the arithmetic rule. Is it clear? Please make a note of this in your sheet of paper. This is very important problem. Once it is asked for 8 marks or something, I think I just don't remember the marks what they are given. Then normal distribution law, second one. So in this case, the summation of the tolerance square is equal to sum of the squares of the individual tolerances. So therefore, so what you can do over here is, so we can get the values of this 4U square is equal to UA square. The p-spot tolerance is U is equal to 0.1 millimeter. Very clearly you can see that one. All these things you can put it as a disadvantage. Is it clear? So this is one problem, very important. Simple problem looks, but very important problem from the examination point of view. Please make a note of this. If you have any clarification, you can just ask me. And how much labor there is, how much cost, what is the power generating capacity. All these things you can answer. And so many other intangible issues that we can answer from this one. Now, okay. Next, I will move to the third one. Normal law with the truncated. So normal law with truncated, sigma a square is equal to sigma t whole square, which is equal to 4 times sigma t square. So this is summation. So all these things will be available in the debt handbook. I will give you the debt handbook. Don't worry. I don't know where I missed it actually. So I'm just searching for that debt handbook. So once I get, I will just upload all those things in your classroom. Don't worry. So now sigma t is sigma a by 2, but sigma a is UA by 3. Okay. So UA by 3 is equal to 0.066 millimeter. Sigma t is 0.44 times U. So 0.44 times U is equal to 0.66 by 2. So the p-spot tolerance for normal law with the 1 sigma truncated. So you are going to get U is equal to 0.075 millimeter. So this is the one they ask for 6 to 8 marks in your examination. Very simple problem it looks. But still, it has been asked, so it is better to learn this, how to do these things. Is it good? So UA is 0.02, 0.02 divided by 3. So which you are going to get 0.006 millimeter, and sigma t is equal to 0.44 times U. So now sigma t is 0.44 times U is equal to 0.606 divided by 2. So you will going to get U value will be equal to 0.075 millimeter. So this is how we will going to solve this problem. Yeah, any clarification, my dear students? Could I able to get this? Everybody?
Okay.
Yeah.
Yes, sir.
Right. Okay. What about that problem what I given in the last time, last class? Could you able to solve those problems?
Yes, sir.
Okay, I think some of the students they are already posted in the Google Classroom. Right. So this is
Sir, for 1 sigma truncated and 1.5 sigma truncated, we are getting the minimum clearance as negative only, sir. Both the problems.
Yes, sir.
Negative you are getting.
Yes, sir. Even Sukrut asked that question.
Okay. Okay, I will check it out. I will check and I will just come back to you in the next
Yes.
class. Okay. Right. Yeah. So this is the completion of module 1 actually, right? So from tomorrow we have to start module 2 or module 3. We will start with the module 3 tomorrow. So till now what we discussed in module 1 is starting from the phases of major phases of design, and then moving on to the effect of manufacturability on manufacturing processes on the design, effect of metal properties on the design, and we discussed different material selection processes. And later part we just shifted to the tolerance analysis, where we discussed the different terms like a mean, variance, kurtosis, or what you call it as the process capability, like that different things we had discussed. And also we just switch over to the tolerance analysis, means tolerances, cumulative effect of tolerances, and different laws, and we solved some problems. So these are all basic things which is very much required for you people to uh, apply these concepts in the DFMA technique. So design for manufacturing and assembly technique, right? So I will take one simple case study. So with your very simple knowledge, okay. So how you can apply your concept of DFM, design for manufacture. Okay. So, and also I will take one case study from MS Ramaya School of Advanced Studies. So they have given one very beautiful case study there. So there we will going to discuss what are the different 7 steps involved in DFME, and then how we can go about implementing this DFMA in a simple thing. Okay. So let us just take one simple case study over here. Yeah. Is it visible for everybody?
Yes, sir.
Yeah. So it is a ballpoint pen. Okay. So it is a ballpoint pen assembly we have shown here. Okay. So generally the ballpoint pen, I'm checking with a very simple product. Okay. So why? Because when you say a design for manufacturing means, so the most important thing is the cost. So you are reducing the cost. So how do you reduce the cost? So I think I've already discussed in many places how the cost can be reduced. So basically from starting from the material cost to the manufacturing cost to the uh, what the sales cost, what the marketing cost, like that. There are plenty of many cost elements will come into the picture, and all those things, and along with that profit. So the total cost of the or the final cost of the product has been will be assigned. Okay. So now I have taken a very simple ballpoint pen over here. This is a one simple case study what I'm just discuss. So what basically it will have a ballpoint pen. So it will have a cap, okay, then head, then ink, tube, body, and a button. Okay, so this is the assembly you can see over here. The cap, the head, body, ink will be filled in the tube, and finally the button. Okay, so how many components you can see in this part? 1, 2, 3, 4, 5, and 6. Okay, there are 6 components of a ballpoint pen. Okay, so now it has been assembled in this way. Okay, so now they have written the connection diagram for ballpoint pen also. Look at here, connection diagram they have written. I think you can understand this. So this is the body, head, tube, ink, and the button and the cap. Is it clear, my dear students? So I'm just taking into the how you can apply the concept of DFM. Okay, so this is how generally we start. So now I think you have seen the ballpoint pen. Am I right? So what I want from you people is it possible? So you know what is the actual cost of a ballpoint pen now? Am I right? So is there any possibility with your own ideas? Is it possible to reduce the cost? If I take, let us take the cost of a pen is around 10 rupees. If I take, it is a good quality pen, a branded pen, 10 rupees. Now what I want from you people is, so if it is a 10 rupees pen, so how the 10 rupee has come into the picture? So what makes the company to keep 10 rupee as a cost of a pen, and out of which what are the cost elements which are involved in that manufacturing of a pen or in the selling of a pen? Okay, and using your engineering knowledge, can we reduce the cost of the pen? If possible, then how? This is what I want from everybody, each individual. I want this now. Okay, I will give around 5 minutes time for each individual, and you can think of, and please make a note of those things, and please I will call one by one, so you can just present your own ideas, so how we can do. So first thing, please make a note of that. So if the cost of the pen is 10 rupees, how they have arrived at 10 rupees? That is very important for me, right? And second important thing is, if anything possible to reduce the cost of the pen, if possible, then how? So these are the three important questions that I want you people from you people. Okay, so take a piece of paper and please just drawing this. Okay, so how and where, how we can reduce the cost, and in what way? This is very important. So you have to think of in a very broader sense. Okay, because it is a very small product. The components are very less, right? And you should be in a position to explain, and you should be in a position to justify your answer. Okay, so I will give you 5 minutes time to everybody. So think over. Okay, and if anything you want to write it down, note it down, and afterwards I will call one by one, so you can just have an interaction with me, so how we can do these things today. Okay, this is why I'm just giving this task for you people is, so you should develop these applications in the sense. So if some MRP, if you say MRP, we will going to call it as maximum retail price. So how that MRP will be arrived? What are the elements which are involved in that MRP? So because you are all engineering students and you already completed your UG, you are already in the masters. So I think by this time you might be having little bit idea about these things. This is what I wanted to do at the end of every module. So we will have one task. So I want, it is just uh, I will be explaining and you are just listening. That is a one part. That is secondary. But now how you can come up with your own ideas, because case studies and application of your design for manufacturing assembly concepts is also very important for me. Okay, so is it right, my dear students? Any clarification with this?
No, sir.
Okay, I will give 5 minutes time from now onwards, please. Okay, so I want you people to just think over. Take it as in a lighter way, in the sense, take it in a different way and try to answer. Don't escape from the things. So I want you people to involve in these things. This is what my intention. That's it. Okay. So please, I will take 5 minutes time. So please think over, and I will come back to you. Okay. Should we start? Is it over, my dear students?
Yes, sir.
Yeah, we're going to start now.
Eliminate the tube, sir.
Yeah, I will come. One by one. I will come.
Okay, sir.
Sandesh. Okay, Sandesh, we will start with you only, Sandesh. Right. Okay. Sandesh, my first question is, when you are arriving at fixing the MRP for any product, okay, so how do you do that?
So,
You take any product, let it be.
so material cost, labor cost,
Okay,
production cost.
okay,
Seeing all those, I will decide them.
okay. Tell me, you have started with material cost, okay, machine cost, labor cost, then what else?
Marketing cost. Sir.
Marketing cost, then then that's it. That's how
No,
we're
sir.
going to
Or
get MRP.
in designing that and all then.
Ah, you have forgotten one aspect here, one important aspect.
Um,
Which one?
assembly, sir. No,
Not
sir.
a. So when you manufacture a product, what you want from that product?
It should complete the required need.
Requirement. That's okay. That is a one aspect. Other than that, what you should be get benefited?
Profit.
Profit should be added, no?
Yes, sir.
For MRP. So profit is also should be added. So maybe you take any method. So if you take 1% or 10%, whatever it might be, that is left to the manufacturer. So that is the what the cost. Okay. Next, second important question. My question is, if you could able to reduce the cost, is it possible to reduce the cost by using your engineering knowledge or technological knowledge what you have?
Yes, sir.
We are talking with respect to the ballpoint pen only. Okay, so how you can go ahead with it?
So we can remove the tube and directly apply the ink to the body only, sir. And head is connected to the body. We'll decrease the material also and assembly time, production time.
Okay.
And overall cost also will reduce this and
directly you will going to fill the ink to that body itself. No tube is required
yes.
according to you. Huh?
Yes, sir.
Okay. Right. Okay, then.
It will be not reusable. It will be like a throwaway.
Use and throw.
Yeah, we
It
can
is
reduce
use
the
and
material of the head
okay.
also, sir.
Material
Quality
of
of the head.
Quality of the head also. Okay. Right. Then anything else?
No, sir.
Okay. This, if there is a question, why do you think why people should not have done this till now? Still they are using refill only.
Sir, quality, sir.
Sorry?
Quality.
No, 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 no. As per your explanation, so just take out the tube, just to fill the ink directly to the body and use it. Okay. So
Yes, sir.
why do you why how you can you explain? See, if these things has to be has people might have think in this way, why it has not been come till now? That process, what you are explaining, it has not come till now. What may be the
So
reasons for this?
people must use their product again and again, so they'll use marketing
Okay,
skills.
marketing skills. Okay, right. Okay. Anything to add, Sandesh?
That's all.
Is there any other means we can reduce the cost of the pen?
No, sir. By the design aspect, and that's all, sir. Marketing and all
Okay, that's okay.
different.
That's I don't want marketing and all those things. I don't want. So if it comes to the manufacturing or the material wise or design wise, so is there any possibility so that we can reduce the cost of the pen? So marketing and sales, that is totally different. Okay, right. Thank you, Sandesh. Yeah.
Yes,
Next.
sir.
Okay. Who is ready next? Danush.
Yes, sir.
Yeah. Tell me, Danush. First question is, what are the costs which are involved in this in MRP? Second one is, so is there any possibility to reduce the cost of the pen? If that is the case, how we can do that?
Sir, for individual components, the definite price will be there, sir. So they have to
Okay.
include everything related to that, and they have to tag a final price for the pen, sir.
Okay. No,
Then when
that's what I want. What are the elements which are involved in that cost? Elements of cost, a cost analysis we can call it as.
sir, sir, body of the pen, sir.
No, 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 no. Make it general. If you say body means it will be made out of a different material.
Yes, sir.
Okay, so it needs to be processed. Like that, every part needs material, every part needs processing, every part needs assembly. That is different. So I want me to put it in a proper way. So how, what will be the elements of the cost which are involved in fixing the MRP of a product?
Sir, manufacturing that those manufacturing machines, sir.
Okay,
Then type of materials which we are gonna select, sir.
okay,
Then the type of ink, like whether it is like gel pen or a ball pen.
okay,
Uh, then color of those inks, sir.
okay,
Then quality of the product, like quality of the material which we select, sir.
okay. Right. So according to you, it is the material cost is the most important thing.
Yes, sir.
The
Material cost and one more is manufacturing cost, sir.
manufacturing cost. Then what else?
The other thing is like well designing that thing in a computer system, sir.
Okay, just take it in this way. So you are the owner of a company and you are manufacturing a pen.
Yes, sir.
So now the task ahead of you is to fix the price of or MRP of that product.
Yes, sir.
So how do you fix? On what basis you will going to fix the cost of the product? It's a price of that cost, price of that product, not cost, price of that product.
So considering the manufacturing cost, like what all have invested on that, and
Very good.
including the amount of percentage of profit, I'm gonna fix that price, sir.
Okay, then only material and profit, only two.
A profit, then if there are some workers working to, related to that, sir.
Labor class, labor
Labor
cost. I'm
class, sir.
sorry, labor
Labor
cost,
cost, sir.
labor cost. Then
Then sir, power supply, sir, electricity.
okay, that is overheads. We can call it as overheads. Okay. Then most important thing.
And based on that customer satisfaction, sir, like which type of pen they need. Based on that, the cost will vary, sir.
No. Dinesh, my question is, see, if you manufacturing one product, right? So it
Yes, sir.
has to reach to the common people. Now, how the people will come to know this product is yours, or means product is there?
Marketing, sir.
That is very important, right? Until unless you
Yes, sir.
marketing has been done. People, the product is there. People never knows. So once you
Yes,
do
sir.
the market, people come to know that this product is there. So that you have to spend more money on marketing also.
Yes, sir.
Okay, so a simple example. So the simple question, Dhanush. So, okay, what are the different means which you will go into market?
Sir, through social media, sir.
Very good. Yes.
One more
Then,
is through TV, sir. Advertisements,
okay, public media.
public media,
Okay,
sir.
okay.
The other thing is like through advertisement boards, sir.
Very good. Yes. There are different ways in which you can market your product. Very good. Right. So all these things, all the cost, material cost, labor cost, profit, and marketing cost, along with that, overheads. Overheads are very important. Electrical, telephone bills, some other things like that. Everything will transportation cost. Everything will come into the picture for you. That we'll call it as a overheads. So all these things taken into account, so then you will go into calculate. So how many products you have made. So if you are making it is in a thousands of product. So for 1,000 product, how much I have got. So that divided by that, this cost you will going to get the cost of a one pen. All right. This is how
Yes, sir.
generally they will going to fix the MR. Right. That is one question. Second question is, if you are given a chance, if you are a proprietor, if you are a owner of a company, if you feel I want to reduce the cost because you might be having a more competitor in the market, you will say I want to reduce the cost of this product because you have to sustain in the market,
Yes,
right?
sir.
If that is the case, so how do you reduce? What will be the major areas you focus in reducing the cost?
Sir, reducing the number of components, sir. Unnecessary components like they can be merged, sir.
How?
For example, in this case, we have to use separate that tube for the filling of the sink, sir. Instead of that, we can directly make use of in injection molding machine. We can directly create a pen in which directly we can fill the ink over to it, sir. Instead of using the tube.
Okay, right. Then, so
Then
when you directly fill the ink means you are just avoiding using the refill. So
yes, sir.
refill means everything. So the material will be saved, the manufacturing cost of the refill will be saved, everything will be saved. Okay, then.
Then if possible, reducing the size of the components, sir.
Okay, size of the component. In which way, lengthwise or diameter wise, cross sectional area wise, how do you reduce?
Both, sir, in terms of length and in terms of diameter, sir.
Okay, so if you reduce both, so what will be the durability of the ink pen? See, if the length is there, means the more amount of ink will be injected over there, and
Yes,
it
sir.
can be used for a longer period of time, isn't it?
Yes, sir.
Yeah, people will also think that. So it is only for 2 days. I could not. Only 2 days I could able to write using this pen. If you reduce the length and if you reduce the diameter both, don't you think so? So you are just think that you are in the other end. You are being the customer.
Yes, sir.
You think if the length and diameter both are reduced, and of course the cost is also reduced. If I think,
Yes, sir.
what is your opinion about this product at that time?
The ink will get over soon, sir.
Yeah, that's another one problem, right? People
Yes, sir.
will say generally what they expect is the pen should be very durable. Durable in the sense it should write for over a period of time. And only thing is they expect to pay the only a very nominal amount. So if you say 2 rupees pen, they pay 2 rupees for a pen, it has to write for another 15 days. Not the
Yes,
10
sir.
rupees pen only for 2 days.
Yes, sir.
Isn't it? think of you are being on the other end. So then you could think always. Right. Next. So reducing the length, reducing the diameter, definitely it reduces the material. But
Yes, sir.
what will be the opinion about the customer? The feedback from the customer will be the very important thing. Next.
Sir, or else we can do with go with the material selection, sir.
Okay, very good. Yeah. So you can look out for the material which is cheaper than the material what you are using right now. Very good. That's a
Yes,
very
sir.
important exploration you have to do. So you have to think of for a different material. So which will going to cost less than what you are using the material for. Then
Yes, sir. Then, as much as possible, try to simplify the design, sir.
how? How do you do this? How do you simplify the design? Okay, simple. You
Like,
take any one simple example and just tell me in this pen only.
yes, sir.
Hmm.
Maybe the shape of the outer part of the body can be changed little bit, sir. Like too much of curves or bendings. If it's like that, we can
Yeah.
make it to the straight geometry, sir.
Okay. See, that is the case means.
Yes, sir.
So why do you think that the kind of curve and all those things they have made?
One thing is to look attractive, sir.
Okay. Second one.
Other thing is like maybe the grip will be provided, sir.
Yes, the comfortness of holding the pen. Okay. See, problem is so when you make the surfaces flat, okay, so you
Yes, sir.
don't feel holding the pen comfortable. You just try. But what happens when the pens are made of rounded, it is of a circular shape, it can fit to any size or anybody's fingers,
Yes, sir.
but not the flat surfaces.
Yes, sir.
So this is because when you are designing any component, you have to think of the ergonomics point of view also. Even it may be a very simple pen is a very simple, but if you can't hold the pen properly, or if you are not feeling comfortable in holding the pen, then definitely people will reject that pen only. Just imagine, so instead of a circle or a circular shape, if it is a rectangular shape, just think
Yes, sir.
which one you prefer, rectangular shape pen or a square rounded shape pen, circular shape pen?
A rounded shape only, sir.
That's what. That is why they might have think of. So rounded bit is better than compared to that of any other flat surfaces. Okay, then what else you can say, Danush?
Um, that's all, sir.
Okay, thank you very much, Danush.
Thank you, sir.
Next, next who is there? Mohan Ambal. Mohan Ambal, are you there?
It's a,
Ah,
it's a,
what is your opinion about this case study? Hello.
yeah, sir, like they all said material cost
Okay. Your voice is breaking, Mohan Ambal. It's not
manufacturing
clear.
cost.
Hello.
Yes, sir.
Yeah. Your voice is breaking now. Maybe some technical lag might be there.
Can you?
Yeah. Tell me.
Yes, sir.
Still, it
Now
is same problem we are facing.
can you?
Yeah.
Sir.
Tell me.
Yeah, so it includes like all the cost, material cost, manufacturing cost, assembly.
Okay. Then, now if you want to reduce the cost of this pen, so how, with your engineering knowledge, how will you go about?
And the labor cost, marketing cost, all the costs, it includes the MRP
Okay.
rate for the
Okay.
product.
Okay. Now, if you want to reduce the
You
cost,
can do modification in the
within the
design
knowledge,
and
how you can
reduce
reduce the
cost.
cost.
And
Okay.
mm,
Okay.
then
Audio
by
problem is there, Mohanapal. I'm not. Okay. Okay. Right. Sri Harsha, are you there?
Sir,
yes, the
Yeah, yeah, yeah.
network is not proper, so
Yeah, yeah. Network issues.
sir.
Okay, leave it. No problem. Leave it, ma. Okay. Sri Harsha,
Okay.
can you tell me? What is
Yes,
your
sir.
opinion about this case study? How you can go about?
Mm, uh, increase the cost, sir.
No, what are the cost elements involved in this? That's my question. What are the cost elements which are involved in this?
In case more expensive, sir.
Sorry?
In case more expensive, sir.
Yeah, yeah, that's what I'm telling you. That is the case, how we can go about.
Mm, okay, sir. Mm, yes.
Okay. So finally, see what you can do over here is whenever you want to reduce the cost, of the cost elements. So wherever it is possible to reduce the cost, simple example, if you take a material, that's what I was Dhanush was talking about. So wherever it is possible to select a material which can give the same performance as that the previous one used, you are going about it, and you can available. It can be available at the lesser cost. Shreyasha, can you mute your microphone? Yeah. So that you had to think. So where the possibilities of reducing the cost by material. Second important thing is wherever it is possible to reduce the machining. Simple example. So if the head and the cap, that is the what they have shown here, the head and the bottom at this right. So I think you can see at the bottom there might be a threaded one. So threaded caps also used to come. So threaded caps means definitely it will going to leave more machining is required. So threaded on the external thread has to be produced on the body and internal thread at the cap. So this is where you can reduce the cost. Look at that. See, nowadays you are not getting that kind of pen. So think of that. So how we can go about. So machining cost and material cost are the almost 60% of your total cost of your MRP will come into the material cost and the machining cost. So these are the main components which are contributing to the price of a product. So look at that, where it is possible to reduce. So of course, overhead cost, whatever it might be, definitely will be there. So I think you can see nowadays, previously, older days, I think you can see the pen. They used to have the cap. So means at the end, that is button they have given. No, the button was threaded one. Threaded means external threads will be there on the body and internal threads will be there on the button. So they used to lock it, or they will going to fasten the body to the button by means of a threaded joint. So producing a threads is a costlier one. So nowadays you can see the same thing you don't find. Okay, this is where the modification that needs to be implemented. So where you can reduce the cost, how we can reduce the cost, all these things has to come into a picture. Being a mechanical engineering student or design students, so you have to think where I can do that, where I can minimize, what are the elements which are contributing to the cost for us. So this is how can go about in using a DFM technologies. Okay, so and also you have to reduce the number of pods. So don't make use of more number of pods over there. Only few number of pods. So because the head does not have anything to move, make him over anything over here. So just take a head and the tube body as a one, and only button if it is there, and you can insert the refill and you can close it. So this is how we have to generally go about. So this is where wherever it is possible to reduce the assembly of the components, that also you reduce. Okay, so please think over. This is a very simple product I have given. I want you people to just thrown at how the DFM technology can be used. So ultimately, you have to reduce the cost without compromising with the quality and the performance. Is it, my dear students? Okay, thank you for participating in this interaction. Okay, we will meet tomorrow morning at 8:30. So I will be starting the next module in tomorrow's class. Okay, thank you very much.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.